All right, guys. Pretty much just like we did last night. There's three situations. If you look at any of our definitions of trigonometry, for example, you've got sine of an angle equals one leg over a different leg, right? In this case, it's a hypotenuse. You actually have three pieces, right? So it could be any of those three pieces that are missing. If I have any two of those, I can find the third one. So we're going to go over three situations. This situation is if you're missing the angle. So that's where we're going to start. All right. You can read a 40-foot ladder 6 feet from the base of a house. A building code says that the ladder should only be used if it's between 45 and 85 degrees. So my question is, does this particular ladder meet the building code? So what is it that I want to know? Okay. So I want to know, does this angle in between the ground and the ladder, is that between 45 and 85 degrees? So this is clearly my unknown, right? All right. Now we can make some assumptions on this. We can label the rest of this. What do we know the length of the ladder?
40 feet.
So this is 40, right? And that also represents what on my triangle? The hypotenuse. And someone just said that the bottom was 6, and that represents what? The adjacent leg. Okay? Now there is one thing that we skipped that I probably should have mentioned, is in this particular problem, we can assume that that's 90 degrees. Okay? Anytime we're looking at a building or something, a tree growing or a pole in the ground, we can assume that's 90 degrees unless they tell us it's leaning. Okay? So that has to happen because I need a right triangle. Okay, so which one of my definitions best uses adjacent and hypotenuse? That's the cosine. So I want to write down cosine of my angle equals adjacent over hypotenuse. Well, I'm just writing the definition, and now I'm going to fill in the blanks. Cosine of my angle, which is x. My adjacent side is 6, and my hypotenuse is 40. Now, this should be just like last night's, right? It's the angle that I'm missing. So we can find the ratio of 6 divided by 40. You can actually put that in your calculator, find the decimal, right? It's 0.15? Okay, so if you want to, you could take this and change it to 0.15, or you could just leave it as 6 over 40. But in either case, we just talked about, how do I get rid of a cosine? What's the opposite of that? It's the inverse cosine. So I need to do the inverse cosine of both sides. And this will go away. And that's going to leave me with x is equal to whatever inverse cosine of 0.15 is, or, of course, you could just leave that as 6 over 40. So what is the inverse cosine of that? It's approximately 81.7, so maybe 82 degrees. So, oh, I'm sorry, 81.3, so just 81 degrees. All right. And then, of course, you just answer the question, does the ladder meet code? Yes, it does. So now look at this situation. Let's look. We now know the angle. The angle is given to us. But we're missing a leg. So where are these legs that they've given us, these sides of the triangle? Where are they related to the 35? The x is, which one's the hypotenuse? 40. Okay, 40 is the hypotenuse. That's the wrong pen. 40 is the hypotenuse. And where's x? Okay, x is opposite of the 35 degrees, right? Now, I'm going to come back to that in a second, but it is opposite of the 35 degrees. So which one of my definitions best uses opposite and hypotenuse? All right. It's going to be the sine. Look at your definitions. All right, so sine of an angle is opposite over hypotenuse. And again, this is new to me. That's why I'm writing it down every time. And then I fill in the blanks. The sine of my angle. How big is my angle? It's 35. The sine of 35 degrees is x over 40. Now, you don't have to do this, but could you not look up sine of 35 in your calculator?
Yeah.
Press sine 35. What do you get?
Can you?
0.5736. Okay. Could you also look up sine of 35 on that table I gave you? It give you that same thing, right? So just for a minute, I'm going to erase this, but just for a minute, let's pretend this was our equation. How do you solve this equation? So why can't I go back and do that right here? Times 40 times 40.
She didn't want us to write that.
Well, you can, Lee, and it's fine. From here on out, you probably won't write it. What happens to the 40 in the denominator and the 40 that you just multiplied by? They go away. Good. And that leaves you with x is equal to, I switch sides, 40 times the sine of 35. Now remember, you've already told me that the sine of 35 is just some decimal, right? So go to your calculator and tell me.
22.9430.
It's about 22 point... One more time? 9.4. So 22.9. All right.
Wait, wouldn't that be the fourth?
All right. Generally speaking, I don't remember if I mentioned this or not, but we should round sides to the nearest tenth and angles to the nearest whole angle. Okay? That's normally how we'll do most of our work. So there you go. Now you know what x is. Okay? Now, I mentioned I wanted to do this twice. Okay? I'm going to switch colors here. I want to go back and look at this problem again. Okay? I'm just looking up here. Okay? You told me that x was opposite of the 35 degrees, right? And you're absolutely right. But look down here. Could you tell me how big this other angle is?
Yes.
How big is that? It is 55 degrees. How do you know it's 55 degrees?
No, it was 35 minutes, and then that was last, you know.
Okay, good. You remember that the triangle has to equal 180, and since these two are complementary, you know that's 55. So, talk to me about x and 55 degrees. Okay, x is adjacent to 55 degrees, isn't it?
Yes.
So could I have done this problem using the adjacent and the hypotenuse? Yes. What definition uses adjacent? Cosine. So if you wanted to, you could have not redone, but you could have done the problem with adjacent over hypotenuse, and this time it would have been cosine of 55 degrees equals x over 40. Once again, how do you solve? Multiply by 40, and you would have found out that x is 40 times the cosine of 55. Now, before you go too crazy with that, do me a favor. What is the cosine of 55? Just the cosine of 55.
0.5736.
Cosine of 55 was 0.5736. Back up here, what was the sine of 35? Remember what we said yesterday? That the sine of A is equal to the cosine of B? If these two are complementary, do they equal 90? Yes. If these two are complementary, they have the same value. So is it a surprise that you get the same answer, 22.9?
No.
All right. And that's all I wanted to show you. All right. So the information they've given us, where is the 43 compared to the 30? Adjacent. And the H is where? So which definition most clearly uses those? That's tangent. All right. So we want to write down that the tangent of my angle is equal to opposite over adjacent And of course, in this situation, opposite and adjacent is really, oh wait, the angle is 30 degrees. The opposite is what I don't know, the height of the tree. I guess I could put a H. And 43 is the adjacent. So how do you solve?
Times it by 43.
Times it by 43. Pretty straightforward, right? And a lot of you at this point can start showing less and less work. The height of the tree has to be whatever 43 times the tangent of 30 is. So you can just use your calculator or you could use your chart. 43 times the tangent of 30 is 24.8. How high is this rocket after it travels 43 horizontal feet? 24.8. How high does it need to be?
28.
Did it make it?
No, it doesn't.
No. So you can tell that the answer is no. So which pieces have they given me? They've given me the adjacent side. They've given me, well, I want to know the hypotenuse. I don't actually have it. And they give me an angle. Now you mentioned two angles. The 90. The 90 was important because I can't do any of this without the 90. But the 18 is the one I'm going to use, right? Okay. Which definition most clearly uses adjacent and hypotenuse? That's cosine. So the cosine of A is adjacent over hypotenuse. And I fill in the blanks. This time my A, my cosine of my angle, is 18 degrees. Equals 27 over x. Now on the last problem, the x was in the numerator, and I got rid of the denominator. How can I get x by itself here?
Multiply by 27.
Well, that won't do it. If I multiply by 27, then that would be 27 times 27. That doesn't go away.
Multiply by x, 18x equals 27.
All right, there you go. Somebody said it. I'm going to multiply by x. And the x will go away on the right-hand side. Really, it just moved to the left. So this actually has one extra step in it. Now I've got x times the cosine of 18 degrees equals 27. Now remember, cosine of 18, I can look that up in my chart, or I can press cosine 18 on my calculator. That's just a decimal. 0.8 something something, right? How would you get rid of this problem right here if I told you it was 0.8x equals 27? Wouldn't you divide by 0.8? So we're going to do the same thing. We're going to divide both sides by the cosine of 18. This cosine of 18 divided by this cosine of 18 clearly goes away. And I'm left with x equals whatever this is in my calculator. 28.4. Yes, ma'am. She's on her way.
Thank you.
All right. Oh, I see I forgot to hit record. So.